Okay, so next let's talk about VPC peering. So we know the basics. VPC peering is used to connect two VPC privately using the internet internal AWS network. And why do we do VPC peering? Well, because we make them behave as if they were in the same network. So the idea is that we have a VPC A and VPC B, and they have non-overlapping CIDR, and then we create a VPC peering connection, and then we have to update some route tables, but we allow the instances in VPC A to communicate privately to VPC B and vice versa. Okay, for this we must not have overlapping CIDRs, and we'll see this in the future lecture. So the VPC peering connection is not transitive. This is something you should know as well, which means that if you are establishing connection with another VPC, for example VPC C, and you create a VPC peering connection between A and C. So because VPC peering is not a transitive, in transitive, instances in VPC B cannot talk to instances in VPC C. That is just not allowed. Okay, that is just not allowed. For making sure that the VPC B can't talk to VPC C, you need to create your own VPC peering connection. You need to create own VPC peering connection. Okay. Between B and C for it to work, so you can do VPC peering in your own accounts, but also with another alias accounts. For this member, anytime you establish VPC peering, you must update route tables in each VPC subnet to ensure that the instances know what to talk to and where to go through the VPC for the VPC peering connection. Okay, so good to know. So VPC peering can work inter-region and across accounts. And then once it's established, we can reference a security group, have a paired VPC, and that works cross account. So these rules are very helpful. For example, here we are here saying like, hey, I want to allow port 80 from this security group of VPC in my other accounts, or VPC in my accounts, but a different VPC. So using these rules, we are able to reference security groups using other peer VPC, and that makes security very easy to manage. Next, the longest prefix match. So VPC uses something called a longest prefix match. So to select a most specific route to route for let's have an example here with VPC A. VPC A that is paired with VPC B and VPC C, and in this example we can look at, if you can see in your screen, VPC B and VPC B are set up exactly the same way. So they have the same CIDR block, and they have the same subnet CIDR as well. So for example, we definitely cannot pair VPC B and VPC C together, because they have overlapping CIDR, but VPC A doesn't have an overlapping CIDR. But VPC A doesn't have an overlapping CIDR either with either VPC B or either with VPC C, and therefore we are able to create two VPC peering connections. Now the problem is that we have a subnet A with a bunch of instances here, and there's one instance in VPC B we'd like to access, which is 10.0.0.77/32. Which represents one IP, and then we want to be able to say traffic that goes specifically to that instance should go through the VPC B, but any other traffic should go through the VPC C. And so the idea is that we are going to define route tables, and in the VPC A we are going to say anything that is 172 is going to be here going to be local. Anything that is very specific, so they're like 10.0.0.0.77/32 is going to be most specific route here, and is going to be sent to the VPC B, and then anything else 10.0.0.0/16 is going to go to VPC C. So the idea is that this route here /32 is the most specific, it is the longest prefix, and therefore it's going to be having priority. In case there's match or the second rule, and then the other VPC have just a basic VPC peering connection. So once you understand this, that means that anything that's going to be most specific route is going to have precedence over the more larger routes. So this is very intuitive, and but it's nice to point out here. Okay, now what are some valid configurations for VPC peering? Okay, the first one is overlapping CIDR for IPv4. So in case we have two VPC and they share one CIDR, they cannot connect. Okay, this is true if even one CIDR out of many CIDRs defined in the VPC overlap. So in this example, 10.3.0.0 and 10.2.0.0 don't overlap, but because there is another CIDR in another CIDR in VPC B that overlap, then we cannot introduce VPC peering. And this is also VPC B that don't overlap, and then we cannot introduce VPC peering. Okay, and this is also true for IPv6. So as long as there's one IPv4 overlap between the VPC A and B, you cannot peer them even if they have the different IPv6 CIDRs. The second thing is that there is no transitive VPC peering. So we have seen this configuration, it does not work. So if you have a VPC B paired with VPC A and A paired with C, then B and C cannot connect, and they have to be paired to one another. But also there's something called no edge-to-edge computing, and that may be a little bit new to you. So what does that mean is we have this example here, VPC B and VPC A are paired together, and VPC A is linked to a corporate network using either direct connect or a VPN connection, whether you want, right? Now in this example, VPC can connect to VPC A, but it cannot connect to the corporate network through VPC A. The reason is that there's no edge-to-edge routing, and this is also true if you are using VPC B paired with VPC A, and there's an internet gateway in VPC A. It doesn't work because VPC B will not be able to access the internet through the internet gateway or VPC A. So no extra edge routing applies to site-to-site VPN, direct connect internet gateways, NAT gateways, and gateways VPC endpoints for S3 and DynamoDB. So all these things you should remember, you should understand them. Now let's do a deep dive. Okay, so let's go through this example here, where someone comes up in your company and say, yes, I would like to have a central VPC and a central NAT gateway, and that NAT gateway is going to be connected to an internet gateway to connect to the internet, and then I want to have multiple VPC connect to the internet gateway through my central VPC, and that may seem like a good idea. So let's go ahead and have a VPC and a private subnet, and we are going to do a VPC peering connection, and it will work. No, this is an invalid configuration. It will not allow your private subnet to talk to the internet gateway because there is no edge-to-edge routing for NAT devices. So through VPC peering, and that is something you have to remember going to the exam. I will give you a solution as to that problem later, but this is an invalid configuration. And so no matter how many VPCs you are trying to connect to the central VPC, if you have defined VPC peering, then there will be no edge-to-edge routing, and so you cannot leverage a NAT gateway to talk to the internet gateway to have a central traffic going through the central VPC. We will see how to solve this problem in the next lecture. So that's it for the VPC peering. I hope you liked it, and there was a lot of information, and hope you learning one or two also. So this is it for the VPC peering. I will see you in the next one.